done a lot of stuff that's kind of theoretical. Now we're going to do like a really applied one. And this is one called the Leaky Landfill. This is not in your book. This is a separate lab that you'll have to do. And what we're going to do in the Leaky Landfill is to be able to find a hole in a landfill without having to dig it all out. In most sanitary landfills, they put a tough plastic liner under the landfill, okay? And that's to keep stuff from leaking out. Specifically, we have what is called leachate. And leachate, you ever go behind like a garbage truck and you see like this liquid leaking out of the back of it and it stinks? That's leachate. Okay, so you don't really want to drink that stuff. You don't want to get it through the liner and into the groundwater system. So therefore, that's what the plastic liner goes in for. Now, once in a while, these plastic liners can develop leaks. And if the plastic liner develops a leak, you got a problem. Now, in general, they have monitoring wells around and things like that. But there's another way to monitor these systems to watch that they don't start to leak. Here we're going to use electrical methods to be able to find the hole in the liner within a landfill. And we're going to find that hole simply by using geophysical techniques. And this is resistivity. How much resistance to electrical flow do you get? And the idea is if you put electrodes on either side of this plastic liner, you should get no electricity flowing through the liner, because liners will prevent liquids from touching each other, and liquids flow electricity a lot better than most things. But you rip a hole in it, and all of a sudden the liquids are touching each other, and the electricity can flow from outside of the landfill to inside the landfill. And so therefore, by noting that difference, you can actually find the location of the hole by using contours. Of course, use contours for everything. You love them. So that's what we're going to do. We're going to first do a little test on a place with no hole in the liner, see what it looks like, poke a hole in your liner in your landfill, and then use these electrical methods, collect a bunch of data, and then contour it up and find out where the hole is. So now we're going to take a look at the equipment that we need to use when we're going to run this experiment. Okay, and there's a bunch of parts to this, pretty simple to go through. First of all, we have our basic kitty litter pan, okay, and we stole this from a local cat. And what we have in here is we put some sand, and it's wet, and it's got salt in it, okay, make it flow electricity better. Salt does a good job with that. And what we have then is on top of the sand, this wet sand, is a plastic liner. And then on top of that, we put more wet sand. Okay, so what we're simulating is that we have the outside earth, okay, and that's what the outside part is, the plastic liner, and wet sand on the inside would be our landfill. Okay, and so that's what we're simulating here. And what we're going to do then is do a little experiment on it. One of the things we have is this plastic sheet, okay, and this, you'll notice the plastic sheet is all gridded, and it has holes at every place where we get intersection on the gridding. And within those holes then, there'll be a number next to them. And those are all going to be your stations where you're going to take measurements from. Okay, and so that's going to give you your measurement base to be able to do this exercise. In addition to that, we have to provide a source of electricity for it. So what we use for an electrical source is a wire, okay, and this has two probes on it. These are just regular old paper clips. One goes on the outside of the liner, and one goes on the inside of the liner or landfill. Then to test it, we have a resistivity meter or a multimeter, and it's got two probes on it. The two probes then will be stuck in different areas to test what the voltage is at various points around here as we do our tests. In addition, we have, you'll see in your handout, you'll get a sheet that has station number, and you'll see it goes 1 through 63, so it covers every single one of the holes. And then it's got two columns. Voltage test 1, and that's before you poke a hole in the liner. And the second one is voltage test 2, okay, and that's after a hole. And what we're going to do with those is then we'll be able to figure out where the hole is without knowing where it is through these methods. Okay, let's try running the experiment. First thing we need to do is set it up so that it works right. So we connect our battery up to our wires, and the wires then connects to the electrodes, and one electrode goes outside of the plastic and the other electrode goes inside the plastic. So we do not make a circuit because the plastic is in between the two. And that's our electrical setup. Next thing we do is we take one of these probes from the other side. This is for the measuring part. So we use our multimeter. We take one of the probes, we stick it out within the sand inside the liner, but outside the grid. The next thing we're going to do is we're going to take the second probe and we're going to stick it into the little holes in each one of the spots. And what we'll get then is some measurement on the multimeter. And we're going to take that number and then you write that number in on the sheet over here. Okay, so you will be taking these in, pressing them into each hole one at a time, and getting a number, putting it into here. What you'll find in the first one is most of the numbers will be pretty similar as you go around. Now be very careful with the probes, because if you poke it through the hole too hard and it goes through the liner, you screw up the whole experiment. So be gentle as you put the probe through the hole. So once you've gone through each one of the stations, each one of the holes, and gotten a measurement, filled out the entire first column of the chart, then you go and you raise your hand, and your teaching assistant will come over to you, and you will say, you're ready to have a hole put in. Now that teaching assistant is going to make you close your eyes, and they'll come out with a knife, and we'll lift up your grid, and they'll take the knife and bang, right through the liner with it. Okay, and so that hole then will now be a place where you're getting leachate, and that allows the water from above to contact the water from below. Do the test all over again. So you run through the same thing, and once you do, you should notice a difference in the numbers that come off of here. And the same thing is done all over again. The numbers will come up highest when you get into the vicinity of your hole. So then all of a sudden the numbers will change once you get in the vicinity of the hole. You may even have to shift scales because the number went up so high. Once you finish taking all readings for all 63 points for both tests, we're going to graph up the results and we're going to make contour plots of them. So the first thing you do is you look over in your column 1 and you find the corresponding station to the point on your grid. And then you would copy that number, 5.6, over onto the grid. Now you would do that through the entire column until you get the entire set of numbers, set of data from voltage test 1 onto the grid. And the next thing you do then is you contour the entire thing. Now when you contour it, don't expect it to be really easy to figure out, because on the first one, they probably aren't going to be too useful to be able to tell what's going on. So that would be voltage test 1, but it gives you a nice base of comparison. Once you get voltage test 1 done, then you go to your second grid or second piece of graph paper and you look at voltage test 2. So what we'll do then is we will start taking the points from each station on voltage test 2, bringing them over and transferring them onto the grid. And once we get done with putting all 63 points again, then we'll contour up this group of data. And you'll wind up with a contour map. In this case, you look for a big concentration of higher numbers at one spot on your grid. And where you can find those higher numbers, that means you've hit the tear in your liner. Okay, and so you'll contour them up and you wind up with a bullseye, and then you can put your spot on there and say, I think my rip is right here, my tear. And you'll have your TA come over, and the TA will lift out the plastic liner and show you whether you got it right. So if you do the contouring right, find the high spot, you should be able to find exactly where the tear is without having dug a hole.